And the next one is also quite similar in the sense that it's still going to be a type 1 question, but we're going to be asked to do this. Now, you're not told what's on the right-hand side, so it's a bit difficult to tell, but the point is you're still trying to find a whole bunch of combinations. And this time you still have a bunch of numbers multiplied by those combinations. These numbers in this case are in the denominator, which strongly then suggests that you're still going to modify your equation, but this time you're going to modify it using integration to get the over n plus 1 and n plus 2, then further suggests that you're actually not only going to just integrate, but you're going to integrate twice to get to the two numbers. And so we'll show you what we mean by that. So we'll start with our baseline, 1 plus x power n equals, well, it's the sum from k equals 0 to n of nck x to the k. Again, we could write that out. This will be a lot of writing, so I might use sigma notation this time. But try to follow along on the right-hand side if you're having trouble with sigma notation. Just think of what it means, okay? So as before, if this is true for all values of x, then it must be true if I integrate both sides as well. If I can derive both sides, I can integrate both sides. Well, the integral of the left-hand side should be pretty easy. It's very standard. It's 1 over n plus 1. Ax plus b, in this case, there's no a, it's the power of n plus 1. And then there's a plus c for good measure, which I'll put on the left. Don't forget the plus c. Okay. And then on the right-hand side, well, the integral of a whole bunch of sums is just basically the integral of the sum. Is the integral of each term as the sum of the integrals. So basically, it's just going to be the sum from k equals 0 to n. nck is a constant, and it's the integral of x to the k, which is 1 over k plus 1, x to the k plus 1. Okay. So that's going to be the case. Now, as with any integration, there's going to be a plus c. So we need to work out what this c is. Remember that this is now true for all values of x. So we kind of really just want to find a value of x that will help us find out c very easily. I mean, I could sub any number for x, but we really want to find one where it makes it easy. Probably the easiest one you could probably sub is x equals 0. And the reason for that is over here on the right-hand side, you've got x in every single one. You start with x power 1 to x power of, n plus 1. Every single one of them is multiplied by x, which means the right-hand side is just 0. So that means I'm going to get 1 over n plus 1. 0 plus 1 is just 1, so is 1 to the power of n plus 1. So, it's 1 plus c equals, and the right-hand side just becomes a whole bunch of zeros, so that equals 0. In other words, c must equal negative 1 over n plus 1. So that gives me the result that 1 over n plus 1, x plus 1 to the n plus 1, now I have a specific c minus 1 over n plus 1 must equal the sum from k equals 0 to n of nck 1 over k plus 1 x to the k plus 1. I have an identity that is true for all values of x. Of course, though, we need a second one. This is not there yet, so we need to do it again. So we'll do the same thing again. The left-hand side will now be 1 over n plus 1, 1 over n plus 2, x plus 1 to the n plus 2, minus 1 over n plus 1, x plus c, that's the left-hand side. And the right-hand side will now be the sum from k equals 0 to n. nck is a constant, doesn't care. 1 over k plus 1 is a constant, doesn't care. We're integrating x to the k plus 1, which gives us 1 over k plus 2, x to the k plus 2. Again, we need to find out this new c. Again, 0 is probably going to just wipe out the right-hand side. So we'll do that. Sub x equals 0. The right-hand side becomes 0. And you're left with 1 over n plus 1, n plus 2. Sub in 0 means that becomes 1. I'll just leave that out. You can see that becomes 1. Okay. Minus 0, so that just goes completely. Plus c equals 0. That gives me my c. So at this point, I now have my second identity. So I've got 1 over n plus 1, 1 over n plus 2, times x to the plus 1 to the power of n plus 2, minus 1 over n plus 1, x, minus 1 over n plus 1, n plus 2, because that takes the place of the c, equals the double integration on the right-hand side. The sum from k equals 0 to n, nck, 1 over n plus k plus 1, 1 over k plus 2, x to the k plus 2. And this is the identity that we're going to use. But again, the general gist is still the same. You take an identity, modify it if required. In this case, we've modified it twice. And now we want to sub a number in. That's what we're going to do. And we want to sub it in so that we get what we want. Well, what do we want? We wanted to prove NC0 over 1 times 2 minus NC1 over 2 times 3 plus NC2 over 3 times 4 minus ... plus -1 to the n NCn over n plus 1, n plus 2. And we want to work out what that is. And really, I mean, you can look at them one term at a time, but really this one probably gives it away. Because you want to sub in a value for x, right? You want to sub in a value for x. The nck going from 0 to n, I mean, that's the 0, that's the 1, that's the 2, and this is the n. So this is the n. So the ncn comes from the k equals n here. Which means, of course, you've got the n plus 1 and n plus 2. You can see that matches. So really, you want x to the power of something to relate to this thing. So that kind of really pretty much gives away what we probably want x to be in our scenario here. And we can take a look, right? You're going to take NC0. So if it's 0, NC0, you actually want a 1 and a 2. Good. So as we said, you really and you've got plus, minus, plus, minus. So it strongly suggests we're going to sub x equals -1. Now, if you sub x equals -1 into the right-hand side, you can see that you're going to, the first term, when you sub 0, is going to be -1 squared, so it's going to be positive. Everything else literally matches. NC0, 1 and 2. That's great. When you sub the next one, you can have -1 to the power of 3, which is, of course, -1 because it's an odd power. And then everything else literally matches. So when you sub x equals -1, you can see that the right-hand side of our expression over here matches the blue, which is what we want. Therefore, what we want to evaluate, therefore, is the left-hand side. Therefore, the sum must equal 1 over n plus 1, n plus 2, times, I'll sub in the -1. I mean, we don't really need this one, but -1 plus 1 to the power of n plus 2. You can see that cancels. We don't really want that one. Minus 1 over n plus 1 times -1. Okay, we're subbing in for x. Minus 1 over n plus 1, n plus 2. The first one that's 0, so it's gone. Negative means it's positive 1 over n plus 1 minus 1 over n plus 1, n plus 2. Of course, putting it all over a fraction means you'll end up with n plus 2 minus 1, which of course means you'll get n plus 1 in the numerator, which then cancels. leaving we with a final answer of 1 over n plus 2. And that's how you do the question. And the technique of taking an identity, modifying it if required, and then subbing in values is essentially how you basically do this type of binomial identity questions.